Frank Gillette.
Thank you, and good afternoon, everyone. It's the first time I've learned that I'm the last thing between the audience and whiskey. That's new. Oh, right, there is one little thing before that. So those folks are going to be really challenged. Well, let me just briefly allow our two panelists to introduce themselves, and then we'll dive into the topic. And I'm going to go to my right first and let you introduce yourself. Thomas, please go ahead.
Thomas Hardjono. I work with a group called the MIT Human Dynamics and Connection Science Research Group, which is in this building, third floor, E15. Our founding faculty director is Professor Sandy Pentland, who, by the way, was one of the three guys who set up this media lab back in '85. And he is also, because this is an IoT crowd, he is also the inventor of Google Glass and is on the board of Google Glass. And I was saying to Frank, in our archive of slides, there is one interesting slide dated '95 where he had an artist sketch a future product. And that future product is what we today call the iPad. Almost verbatim that it's scary, right? So the group focuses on social analytics, a bit of blockchain. In this area, of course, blockchain. There's a little group working on healthcare, new guy working on robotics. And so we have about easily a dozen PhD students with half a dozen postdocs and visitors. Our weekly group lunch is about 40 people from everywhere. So it's a pretty nice, active group. We talk about all sorts of things. We are concerned about data, very concerned about Cambridge Analytica. I was telling Frank, Professor Pentland actually predicted this in 2007, the Cambridge Analytica, and he was interviewed in Wired magazine last week, like I told you so thing 10 years ago, which is kind of great, but also sort of makes you sad. But anyway, so that's where my background is actually cryptography. My interest in IoT goes a long way back. Somebody mentioned roots of trust, TPM hardware. I was a principal scientist at VeriSign, for those who know what VeriSign is. PKI.
You've exceeded your limit of TLAs. No more three-letter acronyms.
So anyway, people know PKI, and that's going to be important for IoT devices, as a few people here mentioned.
All right.
I'm sorry, go ahead.
No worries. All right, Andy, give us your perspective, where you're coming from.
So I'm Andy Stahl. I work for SAP, a reasonably big German software company. I've been working in the area of Internet of Things for a couple of years, and we focus really on the industry side. We're not very much in the B2C side. Our customers tend to be pretty big companies that have a lot of big, complex things they like to wire up to the internet and try to make some good business decisions with. And I've been supporting SAP's efforts to build products and sell solutions to our customers in that space.
Great, thanks, Andy. And where's your accent from? It doesn't sound the same as Dirk's.
Yeah, I'm from the South, and it's an honor to be here in the media lab, and I got to meet some of the folks here, and I was trying to reflect back to many years ago when I went to college, and all the people here were saying, I want to work on something that's 20 or 30 years out into the future. I want to take the insights that I have been taught in my practical education here at MIT or elsewhere and really focus out. And I can tell you probably 80% of my class, the goal they had was to work indoors once they got their degree.
All right. So if I'm to believe some of the hype that I read about blockchain, IoT as a concept is about to crash and burn on the backs of the problem of today's cloud centralized architecture, that if every IoT widget's going to have to phone home to turn in its data, sneeze, poop, anything, that the whole system's going to break because we can't do that, and that blockchain's going to be this amazing savior that enables all these widgets to talk directly to one another, and miracles will happen tomorrow.
Okay, now you can do an ICO just on that. Okay, somebody write a white paper, and you'll probably get $10 million just doing an ICO, just on Frank's words.
So Thomas, it's probably not quite that hyperbolic. However, I'm going to ask you to start us out with the pro-blockchain
Right, sure.
point of view, why is it important? How fast is it happening? Like, set the realistic hype mark for us before Andy tears it down.
So definitely there's a lot of hype for those who were around for the first internet bubble in the mid-90s and into the 90s, the internet. In those days, we did not have speculative investments tied to engineering excellence. And so what we have today is, in fact, the reverse. We have a high speculative investment tied to engineering, not so excellence, in my opinion. So this is part of the problem with the hype. Technologically, blockchain is still nascent. We're talking about toddlers, and I said, no, it's still a baby in diapers, pooping everywhere, and moms cleaning up.
Now you're trying to ruin the point-counterpoint here.
But the key thing is that the arrival of Bitcoin, the Nakamoto proposal, showed that you can actually create interesting peer-to-peer networks that have amazing potential. So one of I'll illustrate by some potential examples. So this actually came out of a master's student in our group. So in his vision, instead of using the peer-to-peer network just for mining purposes, a mining node would have off-chain computational capability and storage. And what you would do is have your data stored there in an encrypted special way. And the special sauce is that you would use a thing called secure multi-party computation, where you, similar to homomorphic encryption, if you guys know what that is, you can do computation on the encrypted data without decrypting. In his case, your data would be encrypted magically, split into several pieces, and stored on the blockchain. And the nodes, the off-chain portion. And if you need to do computation, you could call up the relevant pieces, delegate a node or several nodes to do the computation, and then you get the answer. So it's effectively removing the need for monolithic storage. The days of big databases.
So this sounds like a particular attempt to mitigate some of today's limitations of blockchain then.
That's right, that's right. So could you, because mining nodes, okay, particularly in Bitcoin, they're not unless you live in China, folks know what I'm referring to.
Money anymore.
You're not gonna make much money anymore.
So I think what I hear you saying is there's a lot of theoretical potential to the value of blockchain, but there's still some practical problems to putting it to use.
That's right. And so so people, when I hear people talk about blockchain, I'm not really interested so much in the consensus algorithms and so on. It's the promise of smart contracts that's getting a lot of people interested. We've got a legal group in our group that's focusing on the legality of smart contracts. And in fact, one of the projects we're just starting right now is, can you look at a bunch of robots as IoT devices that can move around, and can you create swarms of these robots that coordinate using smart contracts? And for those who don't know what a smart contract, it's in the old language, it is called stored procedures. If you know what that means in databases. Mm-hmm. SQL databases, stored procedures, the same thing, right? It's just sitting on
a simple deterministic set of instructions.
That's right. And if conditions are met, it's fulfilled, it'll send out instructions to the swarm to do something. And so the business model might be that you want to hire a bunch of robots to clean your yard, right? And all you do is you send payment to someplace, the blockchain, and then if it satisfies the location, the payment, other conditions, the robots come, do your lawn, and they go away. And I don't mean necessarily flying drones, but other interesting little robots. That's kind of the vision thing.
So the opposite end of the spectrum then would be, we look out there, we see almost no implementations of blockchain today in IoT use cases. Are we ever going to need blockchain to make IoT work? And in particular, aren't there a lot of situations where we don't need fancy decentralized peer-to-peer communications and contracts?
I think that you're absolutely right. I mean, when you talk about industrial IoT, I'm going to start right at the very edge. Let's say I've got a sensor on a motor that I'm picking up signals at 300 hertz. Do I think I'm going to try to put that into a blockchain, and over how many motors, over how many gateways, and replicate that database example? We can have 100 gateways in a factory with a half a terabyte to a terabyte of storage. So I'm at 100 terabytes. Now, if I have to replicate just in that factory, you know, 100 times 100, I'm starting to get into some real data storage problems. So my gateways all of a sudden went from $1,000 a piece to now I've got $10,000 or $15,000 in just gateways, just managing the information at the edge. So you know, there's some real practical costs to the explosion of machine data. And I'm going to get into some big extremes. So a fab, a chip manufacturing plant, they have been capturing high quality streams of data to get high yields off of the chips that they make. And a good sized fab generates 6 petabytes of data a day. So it's a single stream of data. If I have to replicate that anywhere, and if I go across a big network, just think what the storage I have to have even to just keep track of one of all of that data.
So you picked, you know, that's shooting fish in a barrel because you can sync blockchain. Well, today's Bitcoin can only handle 7 transactions a second, so dropping 6 petabytes a day on it obviously would put it under. How about you just back up a little bit and, you know, let's just take the assumption they're not going to take all the data in there, and that you're only sort of extracting the insights and individual transactions.
Well,
Isn't there an application?
Well, here's the question. What problem am I solving? Can I do it with blockchain, or can I do it with another technology that answers the question? Because if I'm working within the 4 walls of my factory or the network of my plants, I'm already I trust almost everything in there. And so what problem is blockchain going to solve for me in that manufacturing facility?
So does it have a role in multi-party transactions though?
Well, absolutely. I think the further you get back, out, you know, away from the edge, the further you get away from the edge, the more interesting opportunities arise for blockchain.
Yep.
As the closer you're at the edge, I mean, again, it's a trust thing.
Yeah.
I mean, that fundamentally is the problem blockchain is supposed to resolve. It's a trust issue, and you want parties to cooperate. Well, if I'm in my own entity, I'm going to cooperate with myself. And so that's the question of what am I trying to accomplish with the technology?
Right. So as we're talking here, shout out questions, put your hands up. Mark and I will be watching the audience. But we want to zoom this in on things that you all are interested in addressing in this area of blockchain and IoT. But Thomas, I'm going to turn to you. So what are the circumstances? Why will when and why will it be important to use blockchain technology? What will it enable that's not otherwise possible?
So I'll illustrate by using one of our recent research projects. It was done between us and some guys at Intel. And what made me remember that is there was a question in the back there in the previous security about trust anchors, about updating firmware, and so on. So I worked on the Trusted Platform Module, the TPM chip. You guys know what that is? It's in all your PCs right now.
Yeah, briefly explain it for the audience.
It is a tamper-resistant piece of silicon that has some very limited but well-defined functions like cryptographic key generation, cryptographic storage. It allows you to generate a public key pair, if you guys know what that is, and keep the secret inside and not extractable. So, you know, unless you spend, you know, $5 million with microscopes and so on to scrape that, you know. So the goal of that project was to make this silicon widely available everywhere. And the project started in 1999, believe it or not. A bunch of companies, Intel, IBM, I was at VeriSign, I think even AMD was there, most of the major you know, silicon players. So one of the usability concerns, you know, aside the fact that the home user doesn't know anything about cryptography, was this idea that the user might have to turn this on, use a key, encrypt the file, will encrypt the entire disk drive for security, and when the user loses the key, the user is going to send this machine back to the OEM and say, Dell, HP, IBM, get me back my data. But the whole point of the TPM is you can't get back your data because the keys are not extractable. It's by design not extractable. And so one of the usability processes or designs we created was this idea of ownership transfer. There needed to be a way legally proven way to show that a particular ThinkPad, great machines in those days, a particular ThinkPad was acquired by a customer, and the customer took specific steps, initialization, activation, ownership transfer, and then machine and the whole thing started, right? But this step called ownership transfer needed to be captured. And so this recent project—
Blockchain would enable that.
Right, so this recent project was investigating ways to use the blockchain as a legal mechanism to track this, so that if think about a CEO of a billion-dollar company and he wants his data back, right? And he's going to go and sue the OEM, right? And the OEM needs to be able to say, sorry, there's the record on the blockchain. It's digitally signed by your keys. We countersigned, and it's your problem. Not that they'll say that, but they'll say that. So that was an interesting use case. We have a paper published on that, and it used some of the interesting techniques you'll hear nowadays on zero-knowledge proofs and all that. That's kind of hyped right now in the blockchain space.
So, Andy, how far can existing systems go without blockchain? I mean, it seems like there's a lot of processing you can do at the edge to shrink the insights down to essentially distribute computing without having to use blockchain.
Can I want to react?
Yes,
I've got a reaction.
We're supposed to be brawling here, but we tend to be agreeing most of the time.
I've got a reaction.
Jane, you ignorant slut.
All right, Jane. Now, so
I want to know what the guy's name was. When do we call him an ignorant slut?
So here's an interesting problem with you brought up a positive thing, which is the immutability of the records within the blockchain and being able to trace some things. There's some other fascinating things that can occur because of the immutability of the record. And one of the things that you could have, we're talking about software upgrades and some other things. So the code sitting on top of blockchain evolves over time. And over years, let's say this blockchain has been around for 10 years, one would expect that I would have slow upgrades. Well, let's think about what could happen. Let's say I'm in the 32-bit days, and the guys that are in charge of the code make a decision that they're going to go to 64-bit. So does that mean everybody, and then I've got a business, and I say, I am not going to move my hardware to 64-bit. I actually force a fork in that blockchain. Just by me not upgrading my hardware.
People know what a fork is in a blockchain. So a good example is this Bitcoin.
It's like two countries breaking apart, right?
Yeah, so the block size was initially defined to be maximum a megabyte. And everybody started saying, no, that's not enough, we want more transactions. Then there's somebody said, well, let's double it, right? Easy decision. But if you have 5,000 machines out there acting as nodes, they all have to upgrade the software. And so some of them are saying, I'm too lazy, I'm just going to stay with the 1 megabyte. And so you effectively split the community of nodes, which is what is called a fork, literally.
A split.
A split.
Right.
And the fascinating thing that comes out of that split is, if I actually owned cash and we were doing a system that had some currency involved with it, if I had the cash, I double my money. I actually get money in each fork, the same amount. And so that's a real interesting, from a business perspective, accounting problem.
So I can offer an interesting use case, because I listened through the AWS Dirk's presentation, which I thought, I like it, but then there's you all know there's a privacy concern. So there was a question from the audience about how do you, maybe it was the previous panel, how to incentivize the security guys to do security. One of the topics we are looking in our group is how do you incentivize the consumers in the consumer IoT space to, instead of forcing the data, like in a smart appliance, to be uploaded to the vendor's cloud, how do you incentivize them to say, well, collect all your data in some home box. It could be their PVR with a petabyte of drive. It could be the next generation, Alexa or one of those gateway devices. But instead of the users holding on to it, can you somehow remunerate the user using some kind of a currency blockchain, where if the user says, well, I'll allow you to do analytics on my data for the past year, I'll give you $1, right? If you let me do analytics on all your data from all your smart appliances for the last 5 years, I will give you X. Or, as I keep saying to some smart appliance vendors, why not just go on this model that you will give the home a free washing machine every year, every 3 years, freely installed, but you can upload the data. So that it's a, because we're going to have a, this Cambridge Analytica thing, we're going to have a massive social backlash when consumers realize that home appliance vendors are just, taking data out. They say, well, give me a share of the revenue. That's really what's, and that's, is there a role for the blockchain to sort of spread out the wealth, so to speak?
So, Andy, when I look at this, I see, it seems to me, and what I say to our clients is, blockchain has some application in some very specific and limited places. What do you see when you look out?
Well, I think some of the use cases that I thought were reasonable, and these aren't fully baked out, or some of the track and trace use cases. And let's pick Boeing. I build an aircraft, and I have a lot of problems with counterfeit parts coming in and being able to track those counterfeit parts.
Right.
The challenge so that's a use case. I think the challenge I see with that is we live in this brownfield world where those Boeing aircrafts have been out there for a long time. And there's parts all over the place. Some have been worn out and thrown in a dump. Some have been consumed. And being able to start with something that's out there already, it becomes much more difficult than starting with something, a brand new product.
So let's take a new Boeing coming out of the factory tomorrow.
It'd have to be a brand new model, and no parts have ever been gotten into any distribution system whatsoever. I'd have to have it that clean.
So the
slate.
successor to today's models. Okay, so fine. And that's because even if the next one out of the factory tomorrow, you have to like embed blockchain in all the parts and everything?
I just have to keep track of all the parts. All the parts have to be a piece of the blockchain. So what I'm going to do is I'm going to take that Boeing and explode it into a bomb and know all
materials for those of you who not a thing that explodes, BOM.
And so that and decompose it, and then say this is the serial number of the part that went into this aircraft is on the and I keep track.
This is a great use case.
Right, but that's a giant amount of computation, particularly with the way today that blockchain works. Like there's all these computers that have to record this all over the place, and the network of computers seems to be getting bigger and bigger. How much computation is this?
How much CPU do you guys want to buy?
But at what point is it still practical to compute it?
So this invites this. We need to rethink the way we do computation, right? So even the cloud
blockchain
model,
or in general?
In general, in terms of so the phrase edge computing comes to mind, where you try to localize as much as possible the computation on the data. And it's worth mentioning one of our key projects is a thing called open algorithms. And this notion that you need to move the question, the query, the algorithm to where the data is and get the result back. And this is driven two things, just the increasing size of data sets, and secondly, the thing called GDPR, for those who know what that is. And I think it is May 25th or 26th, for those who are following this, is going to be a big day when the European regulations will say, well, you can't do trans-border data flow. And so if you're...
This regulation applies to every EU citizen regardless of where they are in the world.
I think so. So I was thinking, you might be correct. I tended to think you have to live in Europe physically for it to apply, but that's a good point, right? This is a good point. And so, it's almost like cloud providers may need to either open new facilities in each of these countries or re-architect some of their existing systems to comply with this.
So my understanding that for blockchain to succeed, we have to reinvent our compute model?
That's right. I think there needs to be some rethinking.
So, sorry, different chip architecture or just the idea of distributed computing?
Distributed computing in the true distributed sense, right? I won't say decentralized, distributed. And so that needs to be investigated some more. Research in that space, I think, kind of stalled after cloud came, because then cloud was driven by cost cutting, efficiency, true enough. But now there's this other thing called GDPR, and if you read the regulation, if you're caught violating it, you can be fined up to 4% of global revenue, which is a lot of money for big companies. No longer can you do this.
It's an incentive for governments to find Facebook and Google.
So it's a great business model. I say to the European, when we have visitors come here, it's like, oh, you guys have got to, just keep taxing the U.S. companies. You don't have to innovate.
So,
sorry, did I say that?
yeah. So one of the, just to talk about, and again, I think Bitcoin's one of the greatest proof of concepts that's out there because you can look at it, people are playing with it, there's transactions flying around.
7 transactions a second versus 56,000 at Visa?
Well, that's the, and when you, in 56,000, when you start really talking about in the machine space, like I said, I can have just one little sensor doing hundreds of signals a second, a minute. But just from a cost perspective, on blockchain, or something we can take a look at, to do one transaction on Bitcoin, it's the same energy to power 80 houses for a day.
That's right. The electricity used to mine a block successfully is about 80 houses?
80 houses a day.
And it's great if your government is subsidizing your electricity.
And
so you guys know which country I'm talking about.
And so the other interesting, so you just aggregate that up. So you get into the CO2, get into some green stuff. So 800 blockchain transactions equals 220 tons of CO2. Yeah. And so it's the same CO2 from flying.
So Ethereum is more efficient, I believe.
By about a tenth.
So there's research going on. So there's a bit of a mismatch in the paradigm of computing these blocks. So there's an interesting proposal coming out of the IBM guys, the Hyperledger guys, that reverses the process. So the current sequence of events in Bitcoin is that you do everybody does the transactions in replicating the same thing again, 4,000 times if it happens to be 4,000 nodes. Then you do this proof of work, and then you order, and then you publish. Now they're saying no, do the other way around. So you do your transaction locally, and then you broadcast a proposal. If I apply the result of this running locally, this is the end state of my local database. So it's a small parameter. You broadcast this to every node, and all the other nodes do the same thing. And then if they have agreement, just matching, more than 70%, then everybody says, okay, great, let's execute. So everybody moves at the same time. That's true parallel processing, because you're effectively doing a simulation of the transaction effects before you actually involve everybody else. So with that kind of architecture design, you can get thousands of transactions per second throughput very easily. Again, it requires this is a new architecture. Okay, so you'd have to start with a new blockchain network of nodes, right? So this is why I say we're still in baby phases. Absolutely, we're still in diapers.
So Thomas, let's get you to say when do we get to like teenager 20-something? How fast can this blockchain stuff really have an impact on IoT?
How fast is Bitcoin going to tank?
So wait, Bitcoin has to tank first before blockchain
well,
can succeed?
Again, I annoy a lot of people saying this. I tend to do that all the time. I think this whole ICO thing, doing an ICO with a 10-page white paper is reminiscent to a thing in the Valley that used to be called drive-by funding. Back in the drive-by shooting, this is drive-by. You drive up Sand Hill Road with a car and you pull up, you show 10 slides, and your VC is going to give you, $500,000. We're in this phase right now where, if you have a 10-page proposal and you write beautiful English because you love literature, you get $10 million. Now, then you can sort of say, well, I'll pivot, so you promise you're going to build a rocket and, you sort of build a bicycle. But this is truly, truly hampering innovation. It's distracting. We have a saying here at MIT, we're wasting a lot of clever brains by making them work on web pages, right, and good web design. We're here at MIT to solve real difficult problems. And I kind of believe that until this whole ICO thing gets somewhat, I don't want to say regulated, until the SEC or CFTC come in, I hope sometime later this year, only then will we be able to say, let's solve some of the difficult engineering problems for the good of humanity so that we don't burn electricity.
So I didn't hear a date.
Okay, so I would say in the next 5 years.
5 years. So blockchain nirvana for IoT in 5 years.
For IoT, well, where's IoT going in 5 years?
Billions of widgets, we heard.
So the other guess for IoT is, so it's not about the electronics, right? I've always said this. IoT is not about electronics, it's about data, and it's about coordination, supply chain, and so on. So we have this big privacy problem impending, and I don't know how to solve this, right? Maybe you need regulation there, and we don't like to be regulated, right?
So if blockchain is still an infant, not yet walking, on what time horizon is it usable, and what kind of IoT scenarios?
Well, I think, as I said earlier, it's going to be along some of the track and trace things that we already discussed. I think it's going to be pointing at things in a supply chain, saying I can track and manage them across multiple entities.
So multiple entities.
Because
so an
trust.
ecosystem, right?
Yeah.
So where you have to have multiple parties trusting over time.
That's fundamentally the benefit of blockchain. I'm resolving a trust issue. If I'm just talking to myself, I don't need to have any fancy.
That doesn't sound like very many IoT use cases as a percentage of all those widgets or companies or whatever.
Well, it could be, because I can do cross-company manufacturing. I mean, I can do cross-company supply chain coordination.
Yep.
I can do all kinds of stuff. I mean, sticking with Boeing, Boeing does that for all kinds of stuff that go inside its planes. And so you might get some of that coordination, but there's probably a lot of good systems in place that already do that, because I'm working with a known party then. You know, that's the thing is, from a business-to-business perspective, you know, Boeing takes a tremendous amount of risk. They don't just ask somebody to build something going in the plane. They are doing a lot of research on that company, and is that company going to be around, and what's the quality? I mean, they're not fooling around.
So this gets to the question of governance. So one of the advantages of Bitcoin in particular, blockchain in general, which is our topic, is the idea that it's decentralized governance, that all the parties have to agree to major changes.
Sure.
Now, there was an interesting article that we all took a look at from Willy Ledonverda from November 2016, and he looked at things from the point of view of governance for blockchain. And I think he tied into using some political theory, political economic theory. He tied into a concern that some people have about blockchain, that if enough if enough of the parties around a blockchain are there and agree to work together, they effectively have de facto control.
That's right.
So
That's right.
what's your thoughts on that decentralized governance? How viable is that?
So two things. So the governance in Bitcoin is baked into the whole protocol design. You can't change it. It's there. There was a thing called the DAO, the Centralized Autonomous Organization. People remember that. So this is a proposal. A bunch of guys said, "Oh, we're going to make the first ever decentralized autonomous organization in real space, and we're doing crowdfunding." And they raised up to, I think, 150 million. And on top of Ethereum, thank you, I forgot about that bit. And I was watching this because on the Friday, somebody decided to siphon off some ETH currency, and then by Monday morning, he or she had run off with at least $30 million, right? And so the problem was that the people who designed this to run over Ethereum did not design the governance correctly. There were loopholes that you can do this. And so this brings an interesting question that there are certain governance aspects that need to be done by human beings, and there are certain parts that could be done by smart contracts that are specifically designed for the application of that blockchain. Can't be generic blockchain. And so the question is, what is that percentage? You know, when do human beings, intervene, right? And you can akin this to like the trading floors. The guys in Wall Street, when they do trading, there's these algorithms that run, right? And they look at condition and they buy and sell, according to the algorithm, and you can make a lot of money if you design the algorithms correctly. But there is a way for the human being, the trader, to say halt, right? And this is why you have, I'm not an economist, but there's this idea of flash crashes. For those who know, this has happened in the last a few times. Market goes, poop, crash, and it comes back again, and no one knows why, right? I was like, what do you mean you don't know? You're an economist, you're supposed to know this. No, we don't know this. Like, how? So it's because some of these algorithms are doing some kind of a cascading effect, and then somebody maybe says halt, or there's another algorithm that says back away, and the whole thing, and it takes milliseconds. If you look at the graph, it's less than a second, right? And so, we need human beings, to actually intervene and say, okay, stop, we have to take over. And this is why our group is very big on humans. When we say blockchain, what is the role of human beings in a environment running blockchain? Can we install regulations? So, yeah.
I'll add a little bit.
Yeah, governance.
And you can ask questions.
Okay, I think one of the things that really brings out is there's the rules and the code that enforces the rules. You said that's important, but really what's more important is who makes the rules. That's where the governance comes in, is who's making the rules and drives the direction of the code. And he kind of goes out to Bitcoin and says, look, 90% of the code is written by 5 people.
That's right.
Okay, so, and then the transaction-wise, there's three miners that do 70% or 60% of the transactions.
Mining pool.
This is the people creating new Bitcoin. Right, by computation.
And those guys are the ones that vote on the direction that in fact, the business goes. And that's, in fact, how the fork that we talked about earlier occurred. They had a disagreement amongst those parties, and they just went and created the fork. And so even in Bitcoin, where somebody thinks it's ungoverned, in fact, it's highly governed. And the other thing is with the Bitcoin itself, there was a thing of saying it's going to lower transaction cost. In fact, no bank charges anything close to what a Bitcoin transaction costs to do anything. And so that's some of those, there's some hope that this technology will answer some of those questions, but we're not seeing it play out that way yet.
Questions in the audience before we wrap up? I've got one on the right here, and then I'll
come. A lot of questions. Are you awake? Yeah. Mark is going to give you free Bitcoins for really good. No?
Whiskey is what I think.
Okay.
On the question of trust, the sort of the immutability gets discussed a lot in the context of trust, but with supply chains, the issue is often that someone did not do an inspection, or the thing that is being put into blockchain isn't what it supposedly was.
A missing transaction, an absent transaction.
A missing transaction or simply incorrect information is deliberately put on the blockchain.
So blockchain doesn't resolve that. I can, as a human being, go out and get fraudulent stuff. I could actually buy stuff that's legitimate stuff, and then go over on the on my left-hand side, on my right-hand side, go buy illegitimate stuff and put transactions in the system and send off the illegitimate stuff to somebody. Blockchain, the technology, won't resolve that human interaction with the stuff.
All right.
So I'm wondering, aren't we back to the basic computer science bootstrapping problem in blockchains, where you need a centralized authority to create initialize everything in the beginning, initialize the system. And the reason that Bitcoin has taken off is because there was a centralized authority, Satoshi, who did everything himself, created the Bitcoins, created the wallet, set up the code, and then, and that's it. Then that's not disputable. I mean, forks happened later, but when you started to discuss this, I was just wondering, when you create new blockchains, then you're faced with this problem. How are you going to initialize everything?
Right. So my private opinion, I think Bitcoin is an amazingly successful social experiment. Okay, never has any technology caused so much hype, and I don't know how you get a teenager off his ass, buying hardware, going to the basement, hooking it up, downloading the software, booting it up, and then waiting there to make. How do you do that? I mean, how can you motivate so many people to do something together, right? This is an amazing social experiment. And then it's also at the same time causing some traditional industries like banking to do a bit of soul searching, right? So like, hey, the banks in the UK are kind of concerned. Maybe we don't need banks, right? So yes, you need some bootstrapping, and that is the success of Bitcoin. And that's very hard to replicate until you get a successful or a good incentive model. The incentive for the youngsters, the teenager, is getting money to buy something, right? Coffee. And I think if you talk to the original CTO Gavin of Bitcoin, he back in 2008, he was literally giving away Bitcoin for the asking, because there was just like 6 guys. Like this is funny money, right? And so how do you incentivize people to participate in a collective manner to create the next blockchain system?
Well, I think two comments of.
And then we've got a question in the audience. Go ahead.
Bitcoin is a currency, and lots of people can play in it. In IoT, we're going to start playing around with industrial stuff. So I might not have, maybe the businesses themselves have much cleaner alignment of incentives to actually participate.
Well, if you think the computation and the mining comes from the participants in the ecosystem rather than people trying to generate new.
Yeah, so in the industrial space, you might see alignment more quickly, fewer participants, obviously, but it's trying to solve a shared problem that everybody seems relevant in solving.
That's really important. Let's go to the question.
Andrew, you talked about factories kind of trusting themselves, but nobody in that factory built the device or all of the devices that are being connected. Is there no role for blockchain in authentication of the devices themselves?
It's kind of interesting. We had a discussion.
Security, blockchain and security.
So the security isn't at the device itself. And I'll give you the example. The Stuxnet is a great example. And there's an example from Iraq where at the beginning of the Iraq War, we'd sold Iraq, the United States had sold Iraq a whole bunch of anti-aircraft missiles and all the stuff around it. Somebody raised their hand at Rockwell and said, "Hey, we've got one of their printers off of this, the network for the missiles. Do we want to send it back to them?" And somebody said, "Oh yeah, it's going to be the upgraded version." And so that exact printer that came out of Iraq to be repaired, the United States government put a bug in that took down their ADA system when we initially invaded, during the first Gulf War. So the hardware is a real interesting problem. That's a physical attack. It's hard to prevent the physical attacks.
So the organization called Trusted Computing Group that made the TPM, that was one of its main use cases. So if you have, they call it a manifest, an inventory of all the firmware. So if an OEM, Dell, HP, sells a particular laptop to particularly the corporate customer, the idea was that every firmware, every software that came with it would be digitally signed by a key inside the TPM, so that no one could ever sort of replace it. And so this plays well with the whitelist thing that the IT guys would then say, well, we're just going to export the list, we're going to keep it, and if there's any deviation from the factory model, we'll know immediately, right? So you can extend that to IoT devices, even though some IoT devices are probably too tiny to be able to have a manifest.
We've got a question here on the right.
Yeah, hi, thanks. I appreciate your comments. Very insightful. I'll be honest with you, this blockchain, I'm not talking about necessarily on the IoT side and certainly not Bitcoin. Just confuses the hell out of me. No, I'm serious. I went to a conference out in Santa Clara Valley, and I heard people just like you, well-versed, intelligent, have studied this, that take the total opposite view. They think blockchain is going to take over the world. These are investors that have put skin in the game. Yeah. However, I understand they're talking their book too. So they have a certain point of reference. Right. But relative to blockchain, Frank, you're an independent analyst, Forrester. What is your opinion?
So what we're telling our clients is that we believe blockchain will have applicability in certain circumstances. Well, I think your question was broad to all blockchain and Bitcoin. We see potential for all these various technologies and techniques in the long run. We see an awful lot of experimentation and ecosystem development that needs to take place before it really gels. I think we believe it'll have more of a role to play in financial transactions a bit sooner than it will in IoT. And what we told our clients 18 months ago, and which we still are telling them, is there's, in very limited cases, you can be looking at it, but it's extremely early. We couldn't find then, and there's still very few now, instances of it actually in use. And in so many ways, it still feels kind of impractical, awkward, complex. So in the horizon of things, it's definitely there as something that we're telling our clients to track. We're also telling them to be cautious, not overly aggressive. But there's a number of watch technologies that we say, basically you're in monitor mode and POCs, you find experiments that fit, but don't jump in with both feet and don't ignore it.
I think the comment regarding the four corners of the factory and terabytes of data, I think that I totally agree with what you guys are saying. On the IoT perspective, I don't think it works. But I do think there are certain applications, there's certain elements that this blockchain rollout could bring some pretty fundamental value. But it's difficult to wrap your arms, at least for me, to wrap my arms around it. But appreciate your comments. Very good.
Thank you.
Thank you very much.
Keep going. I think Ziad also had a question after.
All right, Ziad?
Quick question. I don't know if it's applicable for this panel, but I'll ask my question anyway. I hear all this decentralized, it's all exciting. I was mining Bitcoins a few years back. I love it. But governments, our president, everybody is going back to nationalism, to closing, to putting tariffs. Are we on a collision course between the political and governing bodies and the technical world?
I can take it. I'll take a whack at it.
Sure.
Yeah, go ahead.
And I think, though, even within an entity in a country, let's say I've got GE and I'm in their oil and gas division, how I deal with stuff on the shop floor and how I do centralized and decentralized computing can really change. So even on that shop floor historically, or I may have a SCADA system on that shop floor. Right now, because of the compute power that's actually in gateways, I may not decide to use the SCADA system the same way I did before. I might break that apart across 100 gateways, and I might have 100 gateways that have both the storage and even more compute power than the centralized SCADA system that I had before. So that's just an example within the four walls of a factory of where do I put my compute power. When you start going across, organizations, that's a little bit more complex. But still, the notion of that I put my compute power and potentially storage closer to where the data is generated doesn't change.
So needless, I'm pretty sure you heard about the Beijing government making an announcement in January that they were investigating, their own digital reserve currency. Right? This is an interesting eco-political.
They were considering it.
They were considering it.
That's in part because they've been also blocking other forms of digital currency.
So
right?
it's no news that more than 50% of U.S. greenback is actually reserve currency for lots of countries out there, right? Everybody knows that, and so that makes the U.S. in an enviable position. And some other countries might say, well, you know what? What if we're in that position and all of this is currency? Digital currency, not actual stacks of greenback. And so absolutely interesting future. Just on that thread, watch that sort of spot there, because this is going to be a big deal, I think, in the next 5 years.
We have
one question in the back here.
Yeah, right in the middle, and then so before you go, immediately following this, we have people who've been waiting all day to spend 3 minutes getting your attention. So bear with us, and we're going to get to the whiskey very soon. But after this panel ends, there's just going to be a quick fire for what we call our IoT village people. Your question, sir.
As you were mentioning, blockchain is a network technology, and as we are moving into the industrial space, moving away from Bitcoin as a currency, we're going to have to set up these companies. For example, let's take Boeing. If Boeing wanted to use blockchain, who in their entire network, first of all, is going to be the ones who are creating the blockchain? Is it going to be their suppliers or their suppliers? And then from there, if you're going to have a select few number of participants within the network, why have a blockchain at all? And then if you're going to grow the network, then how do you deal with the governance of having more and more people and then the rules of the game keeps changing.
I think you hit the nail squarely on the head. I see as a potential play for blockchain with Boeing, but absolutely you point out, initially Boeing thinks there's enough pressure on them to keep track of parts as they're distributed throughout their network. They can put a lot of pressure on the people that actually buy parts from it, so you're going to participate in it. But then again, why don't I have a centrally stored location? It becomes much more valuable as you get further down the road and the assets age and change hands. And so that set of data not being on Boeing, in Boeing's record, actually becomes much more important in the future. And from complex supply chain perspective, just think about this. If I have an old aircraft or a 2-year-old aircraft and it gets in an accident, I may have somebody that salvages it, and I actually take parts off of a completed aircraft and reintroduces those parts back into a supply chain. How do I capture that information? So in very complex supply chains, I think there's an opportunity, a real-world opportunity to do it. But Boeing is probably going to be the company that has to initially drive and start it.
With that, do you have a quick
No,
rebuttal?
Mark, go ahead. No,
Okay.
it's okay.
I wanted to make sure I interpreted the gesture properly, because I've been disparaged so much during the course
I
of
didn't give you a middle finger, did I?
Yeah, no. But I really want to thank this panel, Andy, Thomas, Frank Gillette,